Today I am discussing about some of an important topics in the course of EST 130 Basic Electrical and Electronics Engineering. As per the KTU 2019 scheme, our modules there are three modules. One is a DC circuits, another one is a magnetic circuits bar an introduction to alternating current, and the last module is an AC circuits and three-phase systems. So we have already discussed both module 1 and 2, and the remaining portion is only for the three-phase systems. So today I am discussing about a detailed discussion about the three-phase systems. So before discussing about the three-phase systems, I am classifying my supply systems. There are two types. One is a DC supply and another one is an AC supply. So I am comparing these I am listing out some of the points. The first point, for a DC circuits, a current will flows in a single direction or a unidirectional current. A unidirectional current will flows, but in the case of an AC, a bidirectional current is flows. So we can represent a DC current is in a single quadrant graph. This is time and this is some voltage or current magnitude. So this is the representation of a DC. But in the case of an AC supply, it is an alternating current. So both 1 and 4 quadrant. So this is voltage per current and this is the time. So means a DC current means a direct current or it is a unidirectional current. But AC current means a bidirectional current. So the second point, in DC we cannot transfer for a long distance. We cannot transfer for a long distance because the power loss, the I square R loss is very high. So due to this problem, we cannot transfer a DC for a long distance. But in an AC, we can safely transfer for the safe transfer for a long distance. And the third point, in DC, the supply frequency is 0. 0 is my frequency for DC. But in an AC, in India, the frequency is 50 Hz. In some other countries, frequency is 60 Hz. Because the frequency is the number of cycle per second. So here the DC, there is no repeating cycle, the frequency is 0. But here the repeating cycle is there, the frequency is equal to 50 Hz or 60 Hz. The relation between frequency and time period is the reciprocal of time period is equal to frequency. So the next point, the production of DC supply, we are adopting, there are three methods. One is a cell or a battery, another one is a DC generator, and the last one a renewable energy technique, the solar panel. A solar panel. So these are the source of production of a DC current. But in the case of an AC, only a single method is an AC generator or the main supply. And another point, in the case of a DC circuit, the resistive circuits, only for the resistive circuits, but in the case of an AC supply, the resistive, inductance and capacitive components are added in the AC circuits. Another point, in the DC system, the supply power factor is equal to 1 because in the case of a resistive circuit, the voltage and current are in phase, so the power factor is 1. So the angle is 0. So power angle is equal to 0, so the power factor is unity. But in the case of an AC supply, the power factor is lies between 0 to 1. The lies between 0 to 1. And the application of a DC supply is normally the DC supply they use for some of the small power application or the home appliance. But in the case of an AC, we are adopting the high power applications or some industries like this. So these are the classification of DC and AC supply. So I'm concluding all the points one more time. In an AC, a unidirectional current flows, or the representation is a single quadrant graph. In an AC is a bidirectional. The graph is both 1 and 4 quadrant graph. A DC supply cannot transfer for a long distance because the power loss is very high. Comparatively, the AC is a safe transfer for a long distance, and the frequency is equal to 0. Here the frequency is equal to 50 Hertz. The source of production is cell or a battery or a DC generator or a solar panel. But in an AC generators, in the case of a DC supply, the resistive circuits we can use the resistive circuits. But in an AC, the resistive inductance and capacity circuits are used. The power factor is equal to unity. Here the power factor is equal to 0 to 1. And the application is some small power applications in the home appliance. And in an AC, the high power applications or an industrial applications. One more point is there, and just shows some different types of DC graph. I'm only shows this is the one type of DC, and this is also a unidirectional current, but it is a pulsating DC supply. So this is a rectifier output. And this is the output of a DC generator also. So this is also a DC representation. But in an AC, the triangular waves, it's an alternating supply, and it is a square wave or a rectangular wave is also an AC supply, whatever it is. Okay. So these are the points in the comparison between AC and DC.